Okay, so in the last segment we were talking about how different techniques have allowed us to get better explanations for the same phenomenon. Sort of a flip-sided interpretation of temporary explanations is one way to avoid incorrect interpretations that are completely temporary because we're wrong is to make sure that our measurements are reliable. Reliability refers to the consistency of a measuring device. So that could be an actual paper and pencil test that we give to a participant and see if they individually score the same way every time they take the test, or it could be we give that paper and pencil test to a group of women in the Seattle area, and then another researcher gives the same test to a group of women in the Atlanta area, and we see if the test produces the same outcome for basically similar people who only differ by region, that kind of thing. That's what we're talking about with reliability. Would the same researchers with the same device produce the same outcome? Would the same device in the hands of other researchers produce the same outcome? Things like that. Now, one way of establishing reliability is to do a test-retest reliability. Now, this is exactly what it sounds like. You give the test to the same individual more than once and see if they get the same score both times. So same score for an individual every time you test them. Now, something that we use in psychology that is highly reliable is IQ tests. IQ tests produce the same basic score for an individual, whether that individual took the test when they were 2 or 22 or 82. Your score will be reasonably close. It's not exactly the same. There's a little bit of variability, but basically the same score every time you take that test. It's highly reliable. Another kind of another type of reliability is inter-rater reliability. Some of you have expressed an interest in behavior analysis. Some of you have expressed interest in developmental issues. Whenever we do research in either of those topics, and actually a lot of other family dynamics topics, things like that, a lot of times we will videotape the participants and then have raters view those videotapes. People who don't know what's going on in the video will be told, okay, so what we want you to do is make a tick mark anytime you see an act of aggression, or anytime you see a sign of contempt on the face of one of the participants, something like that. So the raters are given explicit instructions about what they're looking for. And then they each watch the video and they make check marks anytime they see the behavior that they are looking for. What we're looking for is inter-rater reliability. We want the raters to say the same thing when they're observing these behaviors, or else the behavior is too ambiguous to be included in the score. So if one rater calls that contempt and the other one calls it a neutral face, we don't know what exactly it is, so we have to leave that out. What we want is about 85% of the time them agreeing, for us to be able to say, okay, the raters were looking at the material from the same angle. They had been trained the same way, and the behaviors were unambiguous enough for them to make accurate interpretations. Okay, now, I don't know about you guys, but I personally set my clock ahead a little bit, especially the clock that's in my bathroom and then the clock that's in my car. And it kind of tricks me a little bit. I can't remember how much I've set it ahead, so it really makes me think it's whatever time it is. I really do think that's what time it is. And it causes me to hustle up, get dressed, get out of here, get in the car, don't dally, things like that. Now my clocks are reliably time plus X, right? They are whatever time it is plus some number that I don't wish to even investigate, because then I'll mess up my whole thing. I'll start doing math every morning and I won't hustle up like I should be. So my clocks are reliably giving me the same result, time plus X. But are my clocks actually measuring time? No, they are measuring time plus X. So that gets us at that issue of construct validity. This is the test's ability to measure what it claims to measure. My clock claims to be measuring time, but my clock is actually measuring time plus X. So my clock is incorrect, right? It's not a valid measure of time. It's reliable. So, hold on a second. Yeah, there we go. Let's go back to that IQ test issue. I was just telling you how reliable IQ tests are. They produce the same score pretty much every time you take the test. But we have to remember that an IQ test is only measuring what it claims to be measuring, which is your ability to answer these questions. What is IQ? We don't have an essential definition of IQ, do we? We can't all agree on what intelligence is. But I could very easily say that for the purposes of my experiment, I'm going to sort my participants into high, medium, and low IQ, relying on the Stanford-Binet IQ test. And that's a completely reasonable thing to say, right? I have operationally defined my construct of intelligence as a score on this test. It may not be validly measuring intelligence, it might be measuring something else, but for the purposes of this test, that's what I'm using it for. And any other researcher who wants to replicate my study can use the same measure, or they could say, that's not what I think intelligence is. I'm going to do everything else the same as you did, but I'm going to use a different measure. I'm going to use the ability to count to a trillion. I'm going to use the ability to hop on one foot. I'm going to use whatever I think. And I'm going to operationally define it, and anyone else could use that same measure because it's also directly observable, directly verifiable by other observers. That's the key thing. So I don't know if you're getting the message, but there might be a little bit of error present in these studies that are using operational definitions. But in conclusion, the thing is, we're trying to move science forward. We don't have to have an essential definition of a thing in order for us to be able to move forward. All we have to have is operational definitions. We have to say, this is what I mean by this construct. I mean how long you stared into each other's eyes. I mean that you lapsed into a state of relaxation, sometimes known as hypnosis. I mean a score on an IQ test. That's what's necessary. And then we can move forward. But essential definitions are not necessary. So concepts must be observable so they can be measured. Now, the measurements must be valid for the purposes of what you're using them for. So it doesn't really matter as much that the same person would produce the same score every time as it matters that your test is measuring what it claims to measure. Okay, I thought that was the last thing I was going to say. Okay, so it needs to be valid but not necessarily reliable. The valid part is what we struggle with in psychology, let's be honest. That's what we really struggle with. And we amongst ourselves debate about whether our tests are valid. But we can keep moving forward as long as we're using these operational definitions. Okay, so I'm going to stop here, and the next time I see you, we'll be in another chapter.